Good afternoon and welcome to Maths by Gary Maths Tutorials. You can also find us on Twitter at Maths by Gary if you'd like to follow. So today we're going to take a look at Surds Basics. So what is a surd? A surd is a number which when left in square root form, square root or higher root such as the cube root, cannot be simplified. Remember, the square of a number is that number multiplied by itself. For example, the square of 2 is 2 times 2, which is 4. The square root of a number is the inverse operation of squaring a number, or it's basically just the opposite. So the square root of 4 is root 4, which is 2. 2 times 2 gives you 4. So the cube root of a number is the product of a number multiplied by itself 3 times. So the cube root of 8 would be 2. That's because 2 times 2 times 2 gives you 8. So you're multiplying 2 by itself, so it's 2 times 2 times 2 3 times, and thus gives 8. So now we know what a surd is. We use surds rather than having to deal with decimal figures, and this prevents us having to round up numbers so we can be more exact. For example, root 2 would be 1.4142136. Now this is only to 7 decimal places. This will go on, and it has no exact value. When we decide to leave root 2 as root 2, we call this an exact value. So some examples of surds. Root 16. So root 16 is 4. 4 times 4 gives us 16. So this is an exact value. So exact value. Therefore, it's not a surd. Moving on to root 15. Root 15 has no exact value, so this is a surd. So no exact value, therefore is a surd. Let's move on to the next one, the cube root of 27. So what does this mean? So this is a number times itself 3 times to give you 27. So let's do the opposite. So 27 divided by 3 gives us 9, and then divide by 3 gives us 3. So 3 times 3 times 3. So the cubed root of 27 is 3. So this is not a surd because it has an exact value. The cubed root of 27 is 3. So it's not a surd. Now, finally, the square root of 0.36. Now, if you think about the square root of 0.36, that's simply 0.6, because 0.6 times 0.6 would simply be 0.36. So this is an exact value, therefore not a surd. So now we know what surds are, let's find out how to simplify surds. So let's just look at some of the properties of surds. 2 root 3 plus 4 root 3 plus 3 root 2. How would we simplify this? Well, first of all, if we look at the coefficients, 2 root 3, now imagine that was simply x. Root 3, imagine that was x. So what we can do, because they're the same, root 3 and root 3, we can add this together. So 4 plus 2, 6 root 3 plus 3 root 2. So what we've done is we have simplified 2 root 3 plus 4 root 3 plus 3 root 2 to 6 root 3 plus 3 root 2. Again, move on to the next example, 5 root 2 minus 3 root 2 plus 3 root 3. Now we look at the root 2, because root 2 and root 2 are the same, the coefficient in front, it's simply 5 minus 3, so that's 2 root 2, and then 3 root 3 simply remains the same. So what we've done is we've simplified these surds down. I've got one more example. So looking here, 5 root 3 plus 2 root 2 plus 3 root 7 minus 2 root 3 plus root 2. Now I've put a wee asterisk here at root 2. Imagine root 2, that is simply the same as 1 root 2. So you have 1 in front of the root 2, just so it doesn't complicate things. So that is the same, root 2 is the same as 1 root 2. It's just we don't donate the 1 because convention dictates. So root 3, do we have any other root 3's? We do, we have minus 2 root 3. So starting from the start, 5 root 3 minus 2 gives us 3 root 3. And when we have a longer line of surds, and when we're simplifying, we can score out just so we know that we've used it and we don't use it twice. So the root 3 and the root 3 is gone. Then root 2 and root 2. So 2 root 2 plus root 2 would give us 3 root 2. And again, just score out just so we know we've used that. And then we're simply left with 3 root 7 plus 3 root 7. So we've simplified these surds down, and that's us. So further simplifying surds, we have root 20. So root 20 is the same as root 4 times root 5. So 4 times 5 is 20, which is the same as root 4 multiplied root 5. Now, can we simplify this any further? Yes, we can. We know that root 2 is simply 2, and then root 5 we can't simplify any further, so 2 root 5 is the simplified version of root 20. Now, let's move on to root 50. So, we know that root 50, because of the powers of surds, root 50 is simply the same as root 5 times root 10. So root 5 multiplied by root 10. So root 5 will be root 5. Now root 10, so we simplify down again to simply root 2 times root 5. Now we have root 5 times root 2 times root 5. Now, root 5 times root 5 will cancel out to be 5, because the square root of root 5 times root 5 will give you 5. So we now have 5 root 2. Now there is other ways to do this. If you had noticed that root 50 could have simplified down to root 25 times root 2. You could have saved yourself a few lines of work by noticing that root 25 is 5 root 2. So there you go, exact same correct answer, but there's more than one method to do it. So when you're simplifying surds, keep an eye out for some time saving